I'm Benoit, author of OpenTSDB. So OpenTSDB is first of all, let me ask you real quick show of hands. Who has heard of OpenTSDB prior to OSCon? A sizable number of people. So for those of you who already know about it, just bear with me while I go over the first 3 or 4 slides while I introduce the projects to those who haven't heard about it before. OpenTSDB is a new monitoring system. It's a time series database. So it's something in which you can store all the numbers that come from your applications, machines, and everything, and then see how things are changing over time. It's meant to scale to billions of data points and everything, so I'm going to show you why I built it, how I built it, and what's new with it. So first of all, let me tell you why I built a new monitoring system. Because you might think there's a whole bunch of monitoring systems out there that exist already that have been in widespread use for many years. Why would we need a new one? And I haven't been happy with any of the existing monitoring systems. That's why I built a new one. And some of the problems that I had were like having centralized data storage. So you put all your monitoring data on one or a few number of servers, and if one of those servers fails or the disks crash or burn, then you will lose your monitoring data. It's also hard to scale the storage systems because since they tend to be centralized, it means that you cannot store a whole lot of data in them. A lot of the monitoring systems also, they will deteriorate the data over time. That means that in order to save space, for instance, you might go and take old data and downsample it, and then you will lose the fine-grained aspect of the data because you do this downsampling and it's destructive. The other problem also that I had is I found it very hard with a lot of the common systems to make custom graphs. So I wanted to be able to say I have like a whole bunch of metrics, and I want to take those metrics and correlate them with one another when there is a problem. And I want to be able to do this very easily, arbitrarily. Like there's an outage, I want to see the latency of something against the CPU use of another server and all those things. And in a lot of systems, you have to go and edit configuration files to create new graphs and such. And I don't want to do any of that. And the other issue that I had is the problem of scale. So I want my system to be able to store like tens and tens or hundreds of billions of data points very easily. And I want to be able to get thousands of metrics into the system. And for all those metrics, I want to collect new data every few seconds. So I don't want to have like one data point every minute or one data point every 5 minutes. I need real-time monitoring for my application, business metrics, my systems, my network, and everything. So those are some of the problems that I had with the existing monitoring systems, and that's why I went about creating a new one, which tried to solve those problems. So that's where OpenTSDB comes in. It's the first open source monitoring system that is built on top of HBase, which is also an open source distributed database. The idea of OpenTSDB is collect all the metrics you can imagine, everything in your infrastructure, in your applications, in your business, everything that has a number on it, collect it at a high frequency, store it, index it forever, and then retain this granular data. Never delete data, because disk storage is cheap, so there's no reason to delete data anymore nowadays. I mean, come on, everyone has like at least 2 terabyte drives in your servers, and typically you'll have multiple drives. So everyone has like tons and tons of disk space. Use this to keep your data forever, because then you can go back and mine this data and find interesting things and see how things are changing over time. So that's the idea. OpenTSDB will never delete or downsample or alter your data or do anything to it. You just give it something to store, it will store it and serve it back to you efficiently. It's also making it easy to make custom graphs. You can plug it into your alerting system. It doesn't do alerting out of the box, so you just connect it to your alerting system. Like at StumbleUpon, we use Nagios, so we plug it into Nagios. And you can use it to do a lot of things like capacity planning, troubleshooting, understanding how your systems are changing as you deploy new releases and everything. It's going to give you a really deep insight into your infrastructure, because you keep track of everything on a real-time basis. So every few seconds, you'll take like a snapshot of your entire business and infrastructure, and you'll be able to see how this is changing over time. So as I said, OpenTSDB is built on top of HBase. HBase is one of the more popular NoSQL databases. Why did I go with HBase? First of all, because it's a distributed database, so I no longer have this problem of having centralized data storage for my monitoring data. If a machine fails, I don't lose data. It's just another machine is going to take over the data. It's a very scalable database system. It's reliable and it's reasonably efficient. So all of these give it are the features that I need to build a reliable, scalable, efficient time series database system for a good monitoring system. So some of the key concepts of OpenTSDB is, in OpenTSDB, everything is a data point. What is a data point? A data point is just an observation. A data point is you say, at time t, I observed value v, that's all. It's that simple. Now, if you just have these observations, they don't give you enough information. So we need to know what is this observation about. And that's why a data point has a metric name. So in this example, we're looking at the 1 minute load average of a server. So we know what this data point is about. And one of the strengths of OpenTSDB is you can annotate your data points with tags, which are like key value pairs. And those tags, they're going to give you the ability to view things at different levels of aggregation. So for instance, in this case, if I have web servers and I'm getting the 1 minute load average monitored over OpenTSDB, I can tag the data points with the host name from which this data point came from. And maybe I have multiple pools of web servers. So I might have like web servers doing application stuff, web servers doing static serving. So I can also tag those data points according to the name of the pool of the machine. And then I'm going to be able to say, okay, so show me the load average for this specific machine over the past week, or show me the load average for this entire pool at once. So maybe I'll find that there was a spike in load, but it was only across one pool. So you can tag your data points this way, and this tool is going to be able to, you're going to be able to get different aggregation levels based on those tags. So that's it. It's just a data point is you have a time, a value. It belongs to a metric, and it has a number of tags, and that makes up one specific combination of a metric and a set of tags is a time series. Now, one of the big differences between the way OpenTSDB is designed and what you're typically used to when you look at existing monitoring systems is that OpenTSDB uses a push model. So in a lot of monitoring systems, what happens is that you roll out your monitoring system onto typically a few servers. It's very common to have like one very big massive server sitting in the middle monitoring everything. And this server is going to pull data from all over the place. And OpenTSDB doesn't work this way, it's the other way around. With OpenTSDB, you're going to install collectors on every single one of your machines or devices you want to monitor. And they are going to collect data locally. So that's what is here labeled as tcollector. It's one of the, it's another thing that we wrote at StumbleUpon along with OpenTSDB that we deploy on all our machines, and tcollector is responsible for collecting data from the local machine, from the operating system, from the application. Like say if this is a database machine, for instance, that runs MySQL, then tcollector will collect metrics from MySQL and also from the Linux operating system. And tcollector is then pushing those data points to the time series database. Which here is sitting in the middle. It's called TSD, the time series daemon. It's like your gateway. You never access HBase directly. The fact that OpenTSDB uses HBase is kind of irrelevant for you, except that you have to set up HBase, but other than that, you don't talk to HBase directly. So it's pushing all those data points to the TSDs, so that's why it's a push model. And there are a lot of very nice scaling properties of having a push model. One of the issues if you have a pull model is that you're going to have to, once you exceed what you can monitor with a single machine, you're going to have to say, okay, I'm going to split my monitoring systems on 2 machines. And then you say, okay, so machine A is going to do half of the monitoring work and collect data from all those nodes over here. And machine B is going to do the other half and collect the data from all the other nodes on the other side. And then what happens if machine A is failing? Then you need to have machine B realize that machine A is gone and take over the monitoring duties of machine A, and then you have like this coordination problem that gets worse and worse as you add more machines. Here with OpenTSDB, because the monitoring servers that sit in the middle are all independent from one another, they're not even aware of one another, they don't talk to each other, so you only need to have the agent that's running on every machine find a healthy TSD to talk to. And that's much easier to scale, because once you outgrow the system, once you outgrow your capacity at the TSD level, what do? You just add more TSDs. And that's very easy. You just spin up more instances. And there is no need to say, okay, so who's responsible for monitoring this machine? The machine is responsible for monitoring itself and pushing its data to the monitoring system. That also means that it behaves better when you have certain kinds of failures. Like if you have a network split, or if your machine becomes isolated from the rest of the network, then the agent that's running on the machine will keep collecting data from the machine even though it's disconnected from the rest of the world. And as soon as the machine rejoins the network, the agent is going to be able to push all those data points that have been collected in the meantime, and then you'll know exactly what happened on the machine while it was offline. And that, in a number of failure scenarios, this is actually pretty useful because it's going to give you insight into what happens while your system was like sort of in a split brain mode, or maybe your network was split in two halves. So it's going to give you all this data that you won't lose this data. Whereas if you have a pool model and you have a network split and your monitoring servers end on one side and part of your infrastructure is on the other side, then you will have absolutely no idea what happened in the part of the infrastructure that was isolated from the monitoring servers. So the push model is really one of the big things of OpenTSDB because it has a lot of good properties in terms of scaling and handling failures. So it makes it very easy to scale. And you don't have to use T-collector, but we recommend you do simply because it's easier for you to get started. One of the cool things about T-collector as well is that it makes it very easy for you to write custom collectors. So if you have some kind of proprietary or internal-only applications, for instance, and there is like you have a custom way to extract metrics from your applications or business-level metrics, then it's very easy for you to just write a collector, give it to T-collector, and leave it up to it to then funnel the data into the time series database system. And of course, you can also talk to the TSDs over HTTP, which I'm going to show you in a minute, to get graphs or to generate dashboards and such. So I first talked about OpenTSDB at the Strata conference in February, and back then what I told people was that in order to store a data point, on average with OpenTSDB, it would end up costing you about 12 bytes of disk space, which means that if you had 1,000 machines and you rolled out OpenTSDB to monitor these 1,000 machines with T-collector, then it would cost you about 4 terabytes of disk space per year. Which honestly, if you have 1,000 machines, 4 terabytes is nothing. However, I'm not happy with this. I think 12 bytes per data point is way too much. So I made a bunch of changes recently, and now we're down to 2 to 3 bytes per data point. And I'm not going to stop there. I want to get down to about 1 byte per data point. So what was new since I talked about OpenTSDB at Strata is, first of all, there is a faster write path. So now you get more write throughput over OpenTSDB. I wrote a couple FSCK type tools, so you can debug your data. Like sometimes you can do certain things to OpenTSDB that will lead to like you can how to put this. People have been using it in certain ways for which it wasn't designed, and it was breaking certain assumptions, and so you would end up with data that doesn't look right to OpenTSDB. So those FSCK tools, they will help you understand what's wrong, and for a number of common problems, they will actually help you fix the problems automatically. One of the other things that I'm going to talk more about in a minute is OpenTSDB now uses wider rows in HBase, and I'm going to talk a little bit about HBase schema design and what are some of the good practices when using HBase in designing schemas for HBase. And there's been a bunch of improvements as far as memory efficiency goes. And one of the big things I want to talk about that enabled me to go down from 12 bytes per data point down to 2 or 3 bytes on average is how OpenTSDB is using a more compact representation of its own data. And that led to a reduction of data size by a factor of 6. And I was doing some tests recently on this, and I was able to read back over 6 million data points per second from HBase. So first of all, let me tell you, we're at this time of the year, we're getting pretty close to the first year anniversary of OpenTSDB being the main production monitoring system at StumbleUpon. So when I was talking at Strata, I said that we were collecting 150 million data points per day. As of today, we're collecting more than 600 million per day, so that's a 4x growth over 6 months. In a typical data center. So right now, in that data center that I'm referring to here, we are storing about 70 billion data points, and that's only costing us 720 gig of disk space, which is nothing. So that it became really the only production monitoring system that we use, and I'm going to show you what we do with it. Let me just say that we scaled OpenTSDB effortlessly, and that's one of the really cool things about HBase is I started writing this OpenTSDB in last year, and we started deploying it iteratively and adding more and more metrics to it and collecting more and more stuff to it, and we had nothing to do. We went from like a few hundred data points per second to right now I think we're doing over 6,000 per second, and that was piece of cake. It was really easy. We had nothing to do really. It's just our HBase cluster was pretty small at the time. I think it was only 20 nodes, and we had and it's not only using it's not only for OpenTSDB. We have a whole bunch of applications using it. Some of them are sending them millions of requests per second while we run some batch jobs and everything. OpenTSDB is just one other use case for HBase at StumbleUpon, and we had nothing to do to make it scale. It's just HBase itself is giving all the scaling properties to OpenTSDB, so that was really nice. So let me show you real quick what I'm talking about and how it works and everything. So this is the main UI of OpenTSDB, although I'm aware of at least 3 people who built their own alternative UI. The idea of this UI is, okay, so you're collecting all this data, you're storing it forever and everything, that's great, but what do you do when there is a problem? What do you do when your site is down, it's 3 AM, and you have a hunch that the problem might come from this part of your infrastructure, but how do you go about checking that it's actually the case? And when you take some corrective action, how do you know you actually fixed the problem? So that's one of the things you can do is you can use this UI for this to explore your data and drill down and see what's going on and everything. So let me just refresh the page and I'll start over so you know how I got to this graph. So when you get started, you get this blank form here, and the first thing you need to do is you need to specify some kind of a start time. So I'm going to show you the number of data points that are going to our time series database on a graph. So let's look at the past 1 hour. And the metric for this is TSD RPC received. All right, so what do I get here? I'm getting a straight line that's going up all the time, very slowly. That's not very interesting. Why is that? It's because the time series database system, like a lot of other systems like Apache, MySQL, Memcache, and everything, they have internal counters. Every time they do a certain action, they will increment this counter. Every time the server requests, for instance, they will do +1 on this counter. So you're collecting the value you're collecting is something that's always monotonically increasing. But that's not very interesting. You want to see the rate of change. How fast is this changing? So I'm going to click here, this checkbox, and now I'm seeing the rate of change. So that's much more interesting. Now, I don't know if you noticed, but there is a couple fields, this one and that one, where automatically populated. What does this mean is that the graph I'm looking at here is an aggregate of multiple things. There is multiple hosts and multiple types of counters hidden in this graph, and they have all been summed up together. So I'm seeing the total, which is about 14,000 per second. So I can do one thing, for instance, I can show you one specific type of operation, and now the value went down from 14,000 to about 7,000 per second. So that's the number of put operations we do on OpenTSDB per second for the past hour. So I can go back maybe a day, and you can see this here. So that's the throughput, number of data points going per second to OpenTSDB. You can see this graph is not very easy to read because it's going up and down all the time. Why is that? It's because, first of all, we collect new data every 15 seconds. So this graph is very granular, but I'm looking at one day worth of data with a data point every 15 seconds. So one of the things you can do here is you can click this downsample button, and I'm going to see the average over a 10-minute period instead. And now the interesting thing here is, I said earlier, OpenTSDB is never going to downsample and everything your data. But here in this case, keep in mind, I always preserve the original data. It's just I'm requesting to have the downsample graph on the fly, but the original data is always going to stay there forever. So I will retain the very granular data from my monitoring system forever. And this graph is much more readable. So you can see we are doing pretty close to 7,000 data points per second with this little spike around 4 AM, which is a cron job that's importing some more data in our OpenTSDB system. So what can you use it for? I mean, this is, I'm just showing you how to make graphs right now, but you can actually do very interesting things. So I'm going to show you one of our database dashboards, which might not be very readable if you are sitting at the back, I'm sorry. But essentially the idea is, it's very easy to start from this UI here, and then you can build dashboards that are going to show you various different things, various different graphs on the same page. It's very easy to do so. So in this case, we're looking at a MySQL dashboard, so we have things like the network throughput, we have disk activity from something that's equivalent to IO stat, we have CPU activity, so how much IO weight is my database doing, how much user and system CPU is it doing, how many interrupts per second, how many context switches. I have some disk space information, seconds behind master, some MySQL metrics, how many connections are active, how many requests are going to MySQL, how many slow queries are there, and everything. So it's very easy for you to get all this data. You funnel it through OpenTSDB, you collect the data every few seconds, and you store that data forever. And this is going to give you very granular information, very detailed information that you probably won't be able to get with other monitoring systems because of the scaling problems. So here I can look at, for instance, the last 3 days for this database, and I'm going to see, you can see, unsurprisingly, there is this daily pattern where the load is going down during the trough and up during the peak traffic periods. So this is essentially going to help you understand what your infrastructure is doing, how things are changing over time, have real-time alerting, and when something is broken, because it's real-time, the feedback loop is very small. We're talking about 15 to 20 seconds maybe. If you take some corrective action, then you will get very quick feedback about whether this was effective or not. You won't have to wait a minute to get a new data point and see if it's going back down or up or wherever you want. I want to show you also some of the things that we weren't able to do prior to using OpenTSDB that we are able to do now. We had some kind of cache invalidation problem in our ad system at StumbleUpon, and it was doing something a little bit after midnight that was sending a lot of deletes and selects to one of our MySQL databases, and you can see the effect on this graph. You can see, first of all, this line here that's going up like crazy is the 99th percentile of latency on our site. And you can see that typically the 99th percentile latency, which I put on the right axis, is typically pretty close to 0 seconds, because it's like maybe 1,000 milliseconds or like 1 second or very close to this. And during the outage, the 99th percentile of latency went up all the way up to 1,200 seconds, which is pretty unacceptable. And the other 4 lines are showing you some MySQL metrics from this database on which the ad system was pounding after midnight. And you can see one of the interesting metrics is this one with the purple squares is the number of temporary files created by MySQL. You also have the number of delete statements in red and a bunch of other things. And so I had a hunch originally when this outage happened for the first time that it came from this database. And by looking at OpenTSDB, I was able to find this correlation between those 4 different metrics in MySQL and the latency on our site. And so that pretty much told me that, yeah, here was the problem. And now that I knew where the problem was and that my hunch was right, one of the questions that I had is, why are we seeing this problem just now? What's new? I mean, I was looking at the code and I was like, this code hasn't changed much recently. Has this been happening for a long time? Or is this, was this a latent problem that was just waiting to break? And so one of the things you can do very easily with OpenTSDB, and not so easily with the systems that will downsample the data destructively, is you can go back at any time and see the data down to the second. So when we had this big outage on this day, I was like looking at the previous day and saying, I think we had a problem already on the previous day. Yeah. So on the previous day, we had the same problem at almost the same time, although in this case you can see that the latency, although it was still pretty bad, it wasn't as crazy high. It was only in the 500 seconds, which is also completely unacceptable, but it was twice less bad. But I could tell this was exactly the same problem, because I'm seeing again exactly the same correlation between the metrics from this MySQL database and our latency. So it was exactly the same problem. And as a matter of fact, it paged me also after midnight, so I knew it was the same problem. So I was like, let's go back further in time. Let's see, when did this problem really start? So I was like, okay, let's go back a week. So I'm going back a week, and sure enough, what do we see here? We see that the magnitude of the problem is much less. The spike is a lot more transient, and the impact on the 99th percentile of latency was much less. It went from a horrible 25 seconds to a less horrible 50 seconds. So I was like, okay, this is interesting. It's been going on for at least a week, but we never really noticed it because the magnitude of the problem wasn't that high. So I was like, when did it really start? So I'm going back further. Let's try going back another week. Okay, we still have the same problem. Let's go back one more week. All right, so it seems like starting from mid-June or sort of end of June, really, we started seeing this problem, but it's just no one never really noticed it. The magnitude of the problem was too small for any of us to pay attention to. It wasn't triggering any alarm, it wasn't causing any page. It's just, you know, there would be a slight increase in latency for a minute or two, and that would be it, and no one would really notice this. So that's the kind of thing that you can do with OpenTSDB that I think is really hard to do with other monitoring systems, is because it's keeping this data, this granular data forever, and making it easy for you to go back and look at this data, that it's going to help you understand what's going on in your infrastructure, how things are changing over time. It's going to help you do this kind of very detailed analysis and long-term trending. So if you want to do capacity planning, for instance, then you will be able to look at a longer time period, see how things are changing, make predictions. One of the things we are doing, for instance, is we're trying to look at how fast we are consuming disk space versus how much disk space is available to predict when we're going to run out of disks. And then we, instead of doing what most people do for disk space is they will have, if you use more than 90% of your disk space, then it's a warning, and if you use more than 95%, it's critical, or something like that. Instead of doing that, you can say, if my predicted disk space I will run out of it in, like, say, less than a week, then you send an alert to say, you're going to have to upgrade the disks or free up space within a week, and you want to have a 1 week heads up, for instance, if that's what you need for your provisioning new disks and everything. So you can use it for all of those things, and one of the things we're starting to do at StumbleUpon as well is we're starting to plug more business level metrics into this, so you can also do a lot of things to understand what your users are doing, understand the patterns of the way they behave. And let me give you a concrete example. One of the things that is sort of common wisdom since Google spent a lot of time publicizing this is that the usage of your services is highly correlated to latency. So if you make your service faster, people will use it more. But how much of that is true? And one of the things we did at StumbleUpon is we made a bunch of changes to the way we serve our users to make it go faster. And what we saw was dramatic increase in usage on our site because of the reduction in latency. And thanks to things like OpenTSDB, you can see very precisely how things are changing, how do they correlate together, and how things are evolving over time. So let's go back to the presentation real quick. Let me give you the recipe for a good performance. The first rule is you need to keep good data locality. That means that when you query HBase, for instance, you need to query HBase in such a way that all the data you are going to access is next to each other. So that means you need to know your access pattern ahead of time, and then you need to use a key structure that's going to yield good locality when you access HBase. One of the common problems with HBase is they often make wide rows where you have a lot of tiny cells in those rows with long keys, and they don't actually realize that this is pretty expensive. And one of the things that OpenTSDB does, the secret ingredient, if I can say, is it's using another HBase client, which is called async HBase, and it's a fully asynchronous and non-blocking client, which is written from the ground up to be thread safe and is very efficient for server apps. So it has far fewer threads and less cloud consumption, and it provides more throughput for write-heavy applications. So let me give you real quick an overview of the schema that OpenTSDB uses. There are two tables. The first table is essentially storing a bidirectional mapping between names and IDs. So like for every name of a metric and every tag, we're going to give IDs. So let's say in the case of the metric proc.loadaverage.1minute, I'm going to give it some ID 052. So it's just very simple. It's just a table that has this bidirectional association from ID to a name and a name to an ID. And the reason I'm doing this is because in the main table where I actually store the data, I'm going to put the metric name first in a row key, and I want it to encode it on a fixed number of bytes. So I'm not going to put the string proc.loadaverage.1minute into the row key. Instead, I'm just going to put the ID of this string in the row key. So the first thing that comes in the row key is the metric name, or the metric ID, actually. The second thing is the timestamp. And actually, the timestamp is broken down in two parts. First of all, I'm going to align the timestamp with hour boundaries. So every hour, I'm going to start a new row. And within the row, I'm going to have 1 hour worth of data for a particular metric and set of tags. So that's why I'm taking the timestamp, doing a modulo 3600 on it, and I'll put one part in the row key and the remainder in as the name of the column, the column qualifier, they call it in HBase. And then in each and every cell, I'm going to have my individual observations, my individual data points. So the implications of using this schema is that because in OpenTSDB the access pattern is always, for this metric, give me the data in this time range, from that start date to that end date. It means that I'm going to have all this data, I can access it with a sequential scanner, because I know exactly what is the prefix of the row key that I need to start and stop to get this date range for this particular metric. So this means it's a very efficient access pattern for HBase. It's just a sequential scan, and it's very fast. The other thing that you need is, like I was doing in those graphs where I'm specifying tags here, like in this case I'm specifying a host name, you can see that the tags here are the last things in the row key, and I'm going to push down the filtering of those tags to the HBase region solver. So it's going to be up to the region solver to return only the rows that have the tags I'm interested in. Now let me tell you real quick about one of the new things that are coming to OpenTSDB very soon, are in the feature branch available on GitHub already, is what I call TSDB compactions, which is not to be confused with the HBase compactions. Essentially the idea is, okay, so we have all those observations, they're all independent observations, they're all in different cells, like here in this case I have 3 different data points in 3 different cells. And one of the things people don't realize with HBase is that for every single cell in a row, you're storing the key again. So for every cell, the key is stored along with the value. So in this case, because this representation is misleading, you're inclined to believe that the key is there once, along with 3 values, but in practice, the way the data is stored on disk and in memory in HBase, the key is repeated 3 times, along with the 3 values. And because you can see here that the key is pretty large, it's wasting a lot of space. So what OpenTSDB is going to do now is it's going to take all those values after it knows that nothing else is going to change them anymore because they're too old. It's going to concatenate them all together, write them as one big block. So in this case, I'm adding a 4th value, which is just the 3 values concatenated together. And once I know this has been safely stored by HBase, I can delete the 3 other individual values. Okay? So I'm storing exactly the same data, except now instead of being in different cells, they are all in the same cell. And because of this, I'm going to pay for the row key only once. Now there is one extra thing you have to bear in mind, is that with HBase, when you delete data, you don't actually really delete data. You are just adding a delete marker that says, this data is not there anymore, so it's hidden. If you try to access it, it will tell you it's not there. But you really didn't delete anything, you just added a delete marker to hide it. And that's where the HBase compactions kick in. And HBase also has its own compaction mechanism, which has nothing to do with this, but when HBase is running a compaction, it will take into account those delete markers and really prune the data that's been deleted for real. So after TSDB has done its compaction work, and after HBase has done its compaction work, then what you will end up with on your data on disk and in memory is you will really just have this one key value here, where you have the raw key once, and you have one big value that combines all the values together, and this is far more efficient. That's where you can get the 6x reduction in data size. So last but not least, I want to tell you that OpenTSDB is completely free. You can go and fork it on GitHub and send your patches and everything. There is also a mailing list you can subscribe to if you don't receive enough email already. And I want to thank you. I want to let you know that if you like what you saw, you can set it up in 15 minutes. It's very easy. All you need is the JDK and GNU+ installed, which typically means you run one command to ask your packaging system on your whichever Linux distro you have to install those two packages. Rolling out HBase is actually pretty simple. You can get started with a single node if you want to test it. So you don't need to set up a whole Hadoop cluster just for HBase. You can just set it up on a single node without Hadoop to get started quickly. You can then install OpenTSDB and try deploying tcollector to a bunch of your nodes and see how it works out. tcollector will come with about 100 metrics from the Linux operating system. So you'll get tons of information about CPU activity, disk activity, memory activity, lots of network level stats, how many packets, bytes, discards on all your interfaces, how many sockets do you have open, tons of different things like this. So overall, it shouldn't take you more than 15 minutes to set things up and get started. So thank you for your time, and if you have any questions, I would be happy to answer them. Yes?
So the default client that comes with the CStream is about 100 metrics?
tcollector comes with a bunch.
Default agent.
Yeah, the default installation will give you about 100 metrics for Linux, yes. And it's very easy for you to add more. So currently we haven't open sourced our MySQL collector yet, for instance, but we are working on it. There is a bunch of collectors. There is a collector for HBase, for instance. It's going to give you metrics on how HBase is doing, how many requests per second HBase is doing. I can actually show you this kind of stuff if you're interested. So I can show you this cluster on which this TSDB is running. So yeah, this is like the request rate, which you can see is pretty uneven over time. Let me just downsample it and look at let's look at the past 2 hours. Yeah, so this is giving you like the request rate on this cluster, for instance. So those are the kind of metrics you'll get out of the box with tcollector. One of the things I want to show you as well is how easy it is to drill down in OpenTSDB. I forgot to show you this. So in this case, I'm looking at a specific cluster, and I'm looking at the request rate across this cluster. I'm looking at the sum here because I chose the sum. If I picked average, then I would see the average per host, right? Because host here is one of the tags I didn't specify a value for, so it's been aggregated out. Now you can see there are those spikes in the activity of this cluster. It would be interesting if you have a problem with this cluster to find out what the nature of those spikes is. Is it because all the machines are spiking at the same time, or is it because there is one particular machine that becomes the hotspot? And the way you can do this is if you put a star here, then it's going to show you, it's going to expand all the hosts. And you can see in this case, in this cluster, there is a whole bunch of hosts. I'm just going to hide the key to make it more readable. So we have a whole bunch of hosts in this cluster, and now we have one line per host. And what we can see here is that it seems there is mostly 2 hosts and sometimes a bunch of other ones that are spiking when we see those spikes. So then what you can do is you can look at those individual hosts and see what are they doing, and then you can try to correlate those metrics with other metrics you have to try to understand why they are spiking. So that's pretty interesting. Let me show you maybe another example that's more readable.
Can we click those lines?
Not yet. No, you cannot click those lines yet. But, so this is another example. I'm just showing you. So I have, let me show you the key again. Let me put it above. So in this case, I'm looking at the number of data points written per second to a bunch of different time series daemon. And I can see clearly that the load is uneven in this case because one of them is doing about 6,000 per second while the other one is doing only about 1,000 per second. So I know the host names of the two top ones. So that's how you can drill down, and you can start from high-level overviews. So what we do is we build, at StumbleUpon for instance, is we build dashboards that are giving us like this high-level tactical overview of our traffic and hours and everything. And when there is a specific problem, we can start going into the specific graphs that are steering you in the right direction and drill down. So you'll look, okay, I have the state of 3 different clusters. I see the spike on one of the clusters. I'm going to click on it, then I'm going to expand by host. I'm going to look at all the hosts. Is the problem across the cluster? Is it just localized to a subset of the hosts? So those are the kind of things you can do with your data pretty easily. Yes?
Alerts, for example, the one that's forecasting the expiration of your disk.
Yes.
How hard is that to set up?
So as I said, OpenTSDB is a monitoring system. It's not an alerting system. So it would depend on what kind of alerting system you have right now. And the idea is, so there is an API from which you can get the data back instead of getting a graph. And you can write a script that's going to get this data back and then do whatever you want to do with it and plug this into your alerting system. And so the details of how to accomplish this will vary depending on what kind of alerting system you have. As I said, in our case, we use Nagios. So what we did is we wrote a quick Python script, which is retrieving the data, then fitting some kind of a curve along, like you're trying to find the projection. So you can use some scientific libraries that exist in Python, for instance, to do this very easily. And then you can predict when you're going to hit 0, and then you can say, tell Nagios, this is warning or critical, depending on how much time left you have. So right now, OpenTSDB wouldn't help you do the projection side of things yet. What it will help you do with is getting the data, storing it, indexing it, and serving it back to you, and then you can do whatever you want to do with it.
How many of your machines are named for Nordic gods?
How many of them are named after what?
Nordic gods, right?
Yeah, don't ask me. Those are actually pretty old machines because all the new machines don't have fancy names anymore. So, yes.
Heard of any users using OpenTSDB for other types of time series like scientific sensors?
I haven't heard of them. I've talked to some people who are trying to use it. There was a guy who was trying to use it for medical data. So he wanted to hook up high-frequency body scanners that are taking the information about your blood pressure and everything into this. There was another guy who wanted to store trading data into it. I would be very careful with this because it wasn't designed for this use case. And one of the limitations, arbitrary limitations of OpenTSDB is you don't have sub-second resolution. So the minimum distance between 2 data points is 1 second. Then after this, it's arbitrary. You can have variable intervals between data points. So that's the one thing you have to keep in mind is the minimum distance between the 2 data points is 1 second. Might not be suitable for your kind of use cases, it depends. So if you guys have more questions, I will be happy to answer them. You can just catch me outside or send an email to the mailing list and I will be happy to answer it. Thank you.